This video we're going to be talking about arithmetic series. So previously we've been doing sequences. Now we're going to be doing series. So we'll do arithmetic this time. The next one will be geometric. So just some basics about series. We have infinite series that never end and a finite series that do end. So infinite, there's infinitely many terms. When we talk about series now we are adding all the terms together. Sometimes we write it in summation notation, so it has this little sigma. Okay, so just the difference between sequence and series. Series, you're adding it, the sum. sum, series. Okay, that's how you can try to remember it, is that we're adding the sum of them together. Okay, so these are the equations that we're going to be using. This first equation is the equation to find the sum. So what each of these things represent, this n right here, these both are going to be the same, and it's going to stand for the number of terms, if you can read this. A sub 1 is going to be your first term, and then a sub n is going to be your very last term. Okay, sometimes we need to find n, so we need to find the number of terms, and to do that, we're going to use our explicit equation from the arithmetic sequence. So a sub n is going to stand for your last term again, a sub 1 is going to stand for your first, n is going to stand for your number of terms, which a lot of times you're going to be solving, and d is that distance from term to term. So to find the number of terms, sometimes you might have to use the explicit equation. To find the sum of all the terms added together, you use this equation right here. Okay, so my first question, what is the sum of the even integers from 2 to 100? So the first things you need to always find, you need to find the first term, which in this situation is 2, and you need to find the last term, which is going to be 100. Okay, you also need to find n. N is the number of terms that you're adding together. So if we're doing even numbers here, I go from 2 to 4 to 6 to 8, 100. I don't know how many terms I have. So to find the number, I need to use the explicit equation. So the explicit equation is this, and we're trying to find n. We're trying to find the number of terms. I said a sub n stands for the last term, so we're going to plug in 100. A sub 1 is my first term. The distance I travel from term to term is going to be 2, because we're trying to find the number of terms from 2 to 100. So we have to include the first term and the last term somewhere in that. And then we're going to go ahead and solve it to get the number of terms. So I'm going to distribute this to get 2n minus 2. 2 minus 2 gets me 0, so I got 2n divided by 2. My n is now 50. Now I can find the sum from 2 to 100, including all the even numbers, because I have my n, my a sub 1, and my last term. So it's s of n equals n divided by 2 times your first term plus your last term. So my n is going to stand for 50, so I replace both n's with 50. My first term is 2, my last term is 100. We're trying to find the sum between 2 and 100. That's why we do 2 and 100. Okay, 50 divided by 2 is 25, 100 plus 2 is 102, and then we're going to go ahead and multiply it together and get 2,550. So that's the sum from, if I added up all of the even numbers from 2 to 100. Okay, what is the sum from 4 plus 9 plus 14 plus 24? So first we find our first term, which is 4. Looks like we have our last term, but we don't know how many terms are in between 4 and 99. The distance that we're traveling from term to term, it looks like we're adding 5 each time. So we need to find n again. So I'm going to plug it into my explicit formula. So I plug in my last term, my first term, my distance, and then we solve it again. So I got 99 equals 4 plus, we're going to distribute, so 5n minus 5, combine like terms, negative 1 plus 5n, we're going to add 1, 100 equals 5n, divide by 5, so n is equal to 20, and now I can find the sum now that I have my first term, my last term, and my n. So we're doing s of 20 this time. We fill in both n's. I have to do it between my first term and my last term. 20 divided by 2 is 10. 4 plus 99 is 103. So the sum between all of those is 1,030. So if I kept it going and then added them all together, it would be 1,030. Okay, there are 30 rows of seats in an arena. The first row contains 10 seats. each row after increases by 3. How many seats are in the last row? So I start out with 10, and then I go to 13, and then I go to 16, because I'm increasing by 3 each time. And I don't know how many are in my last row, but I know that there are a total of 30 rows, going from 1 to 30. I know my first term is 10, and I'm increasing by 3. Okay, I already have my n, so this one's a little weird, but I don't know what n represents in this. So what I need to do is find out what my last row is to be able to do the sum. So we're going to do a of 30. We're going to plug it into our explicit equation to figure out what that 30th row actually is. My a sub 1, my d is 3, my n I have this time, which is 30, and I subtract 1. So we're just going to figure out how many seats are in that 30th row. 30 minus 1 is 29. 3 times 29, 3 times 29 is 87. So there are 97 seats. So that answers that first question there, that I have 97 seats in my last row. Now we got to find the total sum. So I already have what my n is. It's 30. So I replace both n's. I have my first row and I have my last row now. So 30 divided by 2 is 15. This is 107. So if I added up all those rows together, I would have a total of 1,605 seats total in the entire arena. Okay, so now we're going to talk about the summation notation. So that's what this weird little e is. So it indicates how many terms you are adding. Limits are the least and greatest values in your series. So this is going to be your lower limit. This is going to represent your number of terms, or your upper limit. And then this is your explicit formula that we're going to find. Okay, so writing a series in summation notation. First off, let's find our a sub 1 and our d. So my a sub 1 is 7. It looks like I have my last term, so if we needed that, we're good. My distance I'm traveling each time is 4. I don't know what my n is. I don't know what my equation is. So first off, let's find our generic explicit equation to plug in right here so I know what I'm using. Okay, so to find my explicit equation, we use our generic explicit equation. I'm not going to fill in my n's because I just want the general equation to get me from the beginning to the end. So my first term is 7, my distance is 4, and then we're going to simplify it. So we're going to distribute 4, combine like terms. So there is my generic equation. I start from my first term, and then I'm trying to figure out how many terms I have. So I need to figure out the number of terms. So what I do to find n here is a sub n always stands for my last term. So I already did my first term. I need to somehow get my last term in there to figure out the number in between them. So I'm going to plug in 207 for my a sub n because that stands for my last term, and we're going to go ahead and solve it. So I got 204 equals 4n. We divide by 4. So n is equal to 51. So that is going to be my upper limit. This means I'm going from 1 to 51. There are 51 terms. So if I wanted to find the sum, I could do that, which we're going to do in a little bit. Okay, so my first term is -5. I'm increasing by 7 every time. So my first job is to find my generic equation. So I got a sub n equals my first term plus my distance. We plug it into our explicit formula. Go ahead and simplify. So I'm going to distribute and combine like terms to get -12 plus 7n. You can write it 7n minus 12 if you wanted to. It doesn't matter. It means the same thing. We're starting at our first term. I need to figure out the number of terms, so I'm going to plop in my last term for a sub n. So 268 equals -12 plus 7n. So I'm going to add 12. So I got 280 equals 7n. Divide by 7. N equals 40. So I'm going from 1 to 40 this time. Okay, this time a sub 1 is 500. My distance I'm traveling is -10. So to find the generic formula, I have a sub n equals my a sub 1, my d. So we're going to go ahead and distribute this to get -10n plus 10, and then combine our like terms to find my explicit equation to be 510 minus 10n. 510 minus 10n. We're starting at our first term. We plug in our last term so that we can figure out how many terms I have. So we're going to subtract 510 to get -500, divide by -10, so n is 50. So there are 50 terms in it. Okay, what is the sum of the series? So if I'm trying to find the sum, I'm going to have to eventually use the sum formula. So to do the sum formula, I need the n, I need the first term and the last term. Okay, so this represents my n, my number of terms. I go from 1 to 70. So I know my n is 70. To find my first term, I'm going to plug 1 in to figure out what it is, because I'm starting with 1. So a sub 1 equals 5 times 1 plus 3. 5 times 1 is 5. 5 plus 3 is 8. So there's my first term. To figure out what my term is for my last term, I now need to plug in 70, because there are 70 terms, so 70 should be where my last one hits. So now I'm going to find my last term by plugging in 70. So 5 times 70 is 350, plus 3 is 353. I have my n, I have my first term, my last term, so I can find the sum. So S of my n is representing of 70. So I plop in my n for both spots. My first term is representative of 8, and my last term is 353. 70 divided by 2 is 35. 8 plus 353 is 361. And then we're going to multiply. So 12,635. So that means if I plugged in the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 70 into my explicit equation and added them all up, because remember, series we're doing sum, this is how much it would be. Okay, so to find a sub 1, it looks like we're starting at 1 again. So I'm doing 1 minus 1 squared. 1 minus 1 is 0, 0 squared is 0, and then my last one I'm hitting at 7. So I do 7 minus 1 squared. 7 minus 1 is 6, 6 squared is 36, and then I'm going from 1 to 7, so there are 7 terms. So I do my sum formula. I have S of 7 equals 7 over 2, my first term, my last term. So 3.5 times 36. So the sum, if I plugged in 1, 2, 3, 4, 5, 6, 7, and added them all up, so I plugged it into that equation and add them all up, is going to be 126. Okay, my next one. We plug in 1. 3 times 1 is 3. Minus 8 is -5, and then we plug in 40 to figure out what our last one is. 40. 3 times 40 is 120. 120 minus 8 is going to be 112. And then my n is representative of 40 because I'm going from 1 to 40. So I do S of 40 equals 40 over 2, my first term, my last term. 40 divided by 2 is 20. -5 plus 112 is 107. We multiply it to get 2,140. So that means if I plugged in the numbers 1 through 40 into my explicit equation, added all those numbers up, the sum would be 2,140. Okay, my last one, we find our first term by plugging in the 1. 1 cubed is 1, and then we find our last one by plugging in the 4. 4 cubed is 64. My n is represented of 4, so I have s of 4 equals 4 divided by 2, my first term, oh my goodness, plus my last term. 4 divided by 2 is 2 times 65. We got this sum being 130. So if I plugged in 1 through 4 into my n cubed, so 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed, the total should be 130.